Hey there, welcome to this beginner-friendly deep dive into the Docker fundamentals. In this video, I will break down the core building blocks, Docker images, containers, registries, and more, all in plain simple terms. And then we will zoom out and learn how all these concepts fit together through a very simple, clean Docker workflow. Before we get into the hands-on, I will walk you through how to install Docker on Windows, Mac, Linux. So no matter whatever you are using, you will be ready. And finally, towards the end, we will see how Docker works under the hood. I will explain all these concepts with real-world examples and analogies. So stick around till the end if you want to get Docker in the simplest terms. Are you excited? Let's get started. Before we get into the technical aspects of Docker, let me start with a very simple analogy. Think of Docker like cooking in your kitchen. You need a recipe. That's the Docker image. You use that recipe to cook your meal. That is the Docker container, something that is real, running, and ready to serve. And where do all these recipes live? On a shelf. That is the Docker registry, a place to store and share images. Just like you prepare the same dish multiple times from a single recipe, Docker lets you create multiple containers from a single image. Makes sense, right? Now, let's take this further and explore the technical side of Docker. Typically, to run a software application, you would need the application binaries, runtime, dependent libraries, configuration files, and any environment specific settings. Docker image is like a blueprint. It packages all of that into a single portable unit. Everything your app needs to run is bundled together. From these images, you launch containers, which are real running instances of your application. And here is the coolest part. You can launch as many containers as you want from the same image. It's like making perfect copies from a single master recipe. But where does these Docker images live? That's where the Docker registry comes in. A place to store, manage, and share your Docker images. You would have heard about Docker Hub. It's one of the most popular public Docker registries. And there are others too: GitHub Container Registry, GitLab Registry, and cloud-based registries from AWS, Azure, and Google Cloud. All of these registries make it easy to share images, work with your team collaboratively, and deploy consistently across any environment. Now let's break down the difference between a VM and a container. A VM runs a full-blown operating system on top of the hypervisor. This means every VM has its own OS, making it heavy and resource intensive. Booting up a VM can take minutes and eats a lot of system resources just for small apps. On the other hand, containers share the same host OS kernel. This means they are lightweight, faster to start, and way more efficient. You can run dozens of containers where you can run only a few VMs. Here is the analogy. Virtual machine is like renting an entire house. You get everything and you pay for the full setup. On the other hand, containers is like renting a single room. You get what you need minus the overhead. The question is when to use containers versus use cases where VMs are the smarter choices. If you're going to build a cloud native, microservices based application focused on speed, scalability, and efficiency, containers are the best fit. On the other hand, if your use cases requires strict security, compliance, and access to specialized hardware, then VM might be the better fit. Docker workflow starts with building an image. But wait, how do you build a Docker image? It all starts with a Docker file, a simple text file where the developer writes step-by-step instructions to package the app. I will walk you through how to write a Docker file in the next video, so hit the subscribe so you do not miss it. Coming back to the image. When you run the Docker build, Docker reads the Docker file, follows the instructions, and creates an image, kind of baking a cake from a recipe. Once built, the image is stored in your local system. Every Docker image has two parts, a name and a tag. Think of tag as the version number. As you improve your Docker file by adding new functionalities or updates, you can build new images with the same name but with different tags. This makes it easy to manage your application versions and roll back if something breaks. And that is a first look at how Docker builds and manages your application. We have built our Docker image. What next? The next step is launching a container, which is like bringing your application to life. You do this with the docker run command. This command, when executed, spins up a live, isolated environment where your application runs exactly the way that you have defined in the Docker file. The best part is you can run multiple containers from the same image, perfect for scaling or testing. So you have built and tested your Docker image locally. How do you share this image with your team for further testing and production deployments? Simple. You push this image to a Docker registry like Docker Hub. And then your teammates make a Docker pull request to download the exact same image. And just like that, they can launch a container on their own machine. That's how you work collaboratively, and there is no more it works on my machine kind of a problem. Same image, same setup, same results every time. Your application is tested in QA, passes UAT, and goes into production, but then a change is requested. The developer updates the code, modifies the Docker file, builds a new image with a new tag, and pushes that newer image to the Docker registry. Again, it passes UAT, great. But then when it hits the production, something breaks. Here is the good thing. Docker makes rollback pretty simple. You just need to redeploy the previous working version of the image. That's it. Next, I'm going to show you how to install Docker on Windows, Mac, and Linux. Feel free to skip ahead to the section that matches your operating system. Go to docker.com. Under the products menu, click the Docker desktop. Choose the Windows version that matches your system, then download the installer. Once it is downloaded, run it and follow the on-screen instructions. Installation might take a few minutes depending on your system resources. At the end, you will be prompted to restart your machine. Go ahead and do it. Once your machine is up and running, launch the Docker desktop. Now, let's fire up a quick command to confirm it is working. Open the command prompt and key in the Docker version command. If you see the version number, you are all set. Docker is now installed and you are ready to go. Now let us install Docker Desktop on Mac. Go to the docker.com. Under the products menu, click the Docker Desktop. Choose the Mac version that matches your system, either Intel or Apple Silicon, and download the installer. Once downloaded, open the .dmg file. In the installer window, simply drag and drop the Docker icon into the applications folder. Now, open the Docker desktop from your application. On first launch, your Mac might prompt for permissions. Go ahead and allow them. Docker will now start running in the background. Let's make sure everything is working now. Open the terminal and type Docker version. If you see the version details, you are all set. Docker is now installed on your Mac and you are ready to build, run, and ship containers. We are going to install Docker Engine on an Ubuntu server. Go to docker.com. Under the products menu, click Docker Desktop, then scroll down and select Linux. On the next page, click Docker Engine in the left-hand menu. This takes you to the official documentation of Docker Engine. Click Install Docker Engine, then choose Ubuntu as your platform. We will use the apt repository method to install our Docker engine. To streamline the setup, copy all the apt setup commands into a script file. Give it execute permission and run it. At the end of the script execution, now the Docker apt repository has been successfully configured on our Ubuntu server. Next step, we will install the Docker engine and its dependencies using the apt package manager. Follow the on-screen instructions. All the dependencies will be handled automatically. Our installation is now successfully done, and let us verify the install. Run the Docker version from a terminal. If you see the version info, Docker is installed successfully and ready to go on our Ubuntu server. Now let's see what is happening inside Docker. It all starts with the Docker CLI, the command line tool that you interact with Docker. When you run the commands like docker build, docker run, docker ps, those instructions are sent directly to the Docker daemon. Docker daemon is a background service that does all the heavy lifting. It listens for commands, pulls the images, builds the images, launches containers, manages networks, handles volumes, and so on and so forth. So here is how it works under the hood. Let's say you run the docker run nginx command. The CLI sends this request to the daemon. The daemon checks if the nginx image is present locally. If not, it pulls it from a Docker registry like Docker Hub, creates a container from that image and starts it. Underneath all of these, Docker relies on the Linux kernel features like namespaces for isolation and C groups to control the resource usage. Each container gets its own isolated environment, but they all share the host OS kernel. In a nutshell, the CLI talks, the daemon listens, and gets all the things done. To recap, we took a deep dive into the Docker world. We explored the core building blocks, Docker images, containers, registries. We looked at the difference between a container and a VM. We then walked through the Docker workflow, installed Docker on multiple operating systems, and finally we looked at what happens under the hood in Docker. Coming up next, we will dive into the Docker files and see how to build custom images from scratch. If you enjoyed this video, give it a thumbs up and drop a comment, I love Docker, below. Do not forget to subscribe so you do not miss what is coming up next. See you.